Trig equations and identities, addendum, page 6. Now this one here, we're still going to use the trig ID for tangent, the sum of two angles, tangent of sum of two angles. And remember that just looks like this. Tangent of A plus B equals the tangent of A plus the tangent of B divided by 1 minus the tangent of A times the tangent of B. And in this case, it's a little bit different than before, because before we always had this as the unknown, but now our unknown is going to be this, I think. Because you see how we know tangent of A plus B and we know tangent of B, but we don't know tangent of A? So it becomes like an algebra problem. So let's do the substitution. We're going to put in what we know. So we don't know tangent of A. And we do know tangent of B is 2/3. And then the denominator would be 1 minus tangent of A, which we don't know. And we multiply that times tangent of B, which is 2/3. So let's, instead of tangent of A, that's kind of difficult to write, we're going to put x, okay? So we'll have 3/5 equals x plus 2/3 divided by 1 minus 2/3 x. So now it's just an algebra problem, right? So we're going to multiply both sides by 1 minus 2/3 x because kind of a pain to have a fraction. So we'll have 1 minus 2/3 x. And then the right side will just become x plus 2/3. And then we'll distribute this 3/5. So we'll have 3/5 minus 2/5 x equals x plus 2/3. Now we're going to combine the x's and we'll combine the numbers. So we'll have we'll add 2/5 x to both sides. So we'll have 7/5 x. We'll subtract 2/3 from both sides. So we end up with 3/5 minus 2/3. 3/5 minus 2/3 we could write with a common denominator of 15. So that would be 3/5 would be the same as 9/15, and minus 2/3 would be the same as 10/15. So we would have negative 1/15 on the left. We would have 7/15 or 7/5 x on the right, and we could reduce these fractions, and we'll end up with negative 1/21 equals x, because we were going to multiply both sides by 5/7. So it would be negative 5/7 divided by 15. Yes, negative 1/21. And that would be the tangent of A. Let's do number 15 now. You can see on this one, let's see, we're going to try to figure out the angle alpha. We do seem to have the angle, the side here and the side here. We also have this side here. You can see that they're trying to set us up maybe for tangent because we do have the opposite over adjacent. Let's name this angle here as beta. And let's write an equation which is the tangent of alpha plus beta, okay? So we'll have the tangent of alpha plus beta. It's going to be equal to the tangent of alpha plus the tangent of beta divided by 1 minus the tangent of alpha times the tangent of beta. And we can see that the tangent of alpha plus beta from this diagram is going to be 8 divided by 10, right? The opposite over the adjacent of this angle, alpha plus beta. So the left side would become 8 divided by 10. The right side would become tangent of alpha, which we don't know, plus the tangent of beta, which we know is 3/10, right? Divided by 1 minus tangent of alpha times 3/10. And so now let's simplify by writing tangent of alpha. We'll just write x. X plus 3/10. And instead of writing 3/10, let's just write 0.3 and 0.8. That's easier, right? Especially I got this big fat marker. 1 minus 0.3 times x. And now we'll multiply both sides by 1 minus 0.3x. So 0.8 times 1 minus 0.3x equals x plus 0.3. We'll distribute the 0.8. We'll get 0.8 minus 0.24x equals x plus 0.3. We're going to add 0.24 to both sides. We'll get 1.24x on the right. On the left, we're going to subtract 0.3 from both sides, so we'll get 0.5. So we'll have x equals 0.5 divided by 1.24. And I'm going to do that. I'm just going to rewrite that fraction as 5 divided by 124. And that, of course, is equal to the tangent of alpha, which is the same thing as x. And I wanted the exact value of tangent of alpha, so I'm going to have to leave it like that. I won't put it in the calculator like I thought I would. Finally, let's go down to 17. We're going to express tangent of these three angles added together in terms of A, B, and C. We could do that by kind of using this formula 2 times, okay? So first we're going to group it. We're going to say, okay, first I'm going to have tangent of A plus B, and then I'm going to have tangent of C, and I'm going to treat those as 2 separate angles. So I'm going to have tangent of A plus B plus tangent of C, and I'm going to divide that by 1 minus tangent of A plus B times the tangent of C. And then I'm going to substitute in for tangent of alpha plus A plus B, I'm going to substitute in the identity again. So I'm going to have the tangent of A plus the tangent of B divided by 1 minus the tangent of A times the tangent of B plus the tangent of C. And in the denominator, I'm going to have 1 minus tangent of A plus tangent of B divided by 1 minus the tangent of A times the tangent of B times the tangent of C. Okay, so we just created this monster expression, which is the tangent of A plus B plus C, in terms of tangent of A, tangent of B, and tangent of C. I might be able to simplify this a little bit, but let's see what else they want to know. Hence, show that if A, B, and C are the angles of a triangle, then the tangent of A plus the tangent of B plus the tangent of C is equal to the tangent of A times the tangent of B times the tangent of C. Well, that is interesting, isn't it? So I assume that if I simplify this expression here, that I would end up with that formula. So let me try to simplify it. So I'm going to make this smaller because I'm going to need some space. Okay, so this whole thing that I just found is equal to the tangent of A plus B plus C. Okay, now let's try to simplify this last expression here. What I'm going to do is I'm going to multiply both the top and the bottom by 1 minus tangent A tangent B, because if I do that, then I should be able to have an expression with less fractions in it, right? So I'm going to multiply the top and the bottom by this expression. And let's see what I get. So I would end up with tangent of A plus the tangent of B plus 1 minus the tangent of A tangent of B times the tangent of C, right? That would be the top. On the bottom, I would have 1 minus the tangent of A times the tangent of B minus tangent of A plus tangent of B times the tangent of C. Okay. I can see now that, let's see, I'm going to distribute the tangent of C to here, between here and here. I'm going to distribute the tangent of C here and here. And so then I'm going to expand that even further. So I'm going to have tangent of A plus the tangent of B plus the tangent of C on top. And then I'm also going to have minus the tangent of A, tangent of B, tangent of C multiplied together. Okay, that's the numerator. The denominator is going to be 1 minus the tangent of A times the tangent of B minus, and now I'm going to have tangent of A times the tangent of C plus the tangent of B times the tangent of C. Okay. Now, remember what this is equal to. This is equal to the tangent of A plus B plus C. And they said, what if A, B, and C are the angles of a triangle? If A, B, C are the angles of a triangle, then if you add them up, you get 180 degrees, right? What is the tangent of 180 degrees? The tangent of 180 degrees is 0. So actually, what I'm saying is this ugly fraction here is 0. And if the ugly fraction is 0, that means that the numerator must be 0. Because whenever a fraction is 0, the numerator is 0, and the denominator is anything it wants to be as long as it's not 0 also. So, if we know that the top is 0, then basically we could say, we could set the whole thing equal to 0. So tangent of A plus tangent of B plus tangent of C minus tangent of A. I'm going to abbreviate it by just writing T's. Tangent of B, tangent C is equal to 0. And if that's true, then what I could do is I could subtract, or I could add tangent A, tangent B, tangent C over to the right side, and then I would just end up with exactly what they wanted, which was tangent of A plus tangent of B plus tangent of C equals tangent of A times tangent of B times tangent of C. So we have the 3 tangents added together and the 3 tangents multiplied together. Okay? All right. And that's it for 17. What about 19? Prove that in the given figure, alpha plus beta equals pi over 4. Okay, so we have alpha here, and we have beta here, and we have pi over 4 here. And it says that this, and this length are all the same length, and this is also the same length, which totally makes sense because if this angle is pi over 4, then of course ED and CD both need to be the same length, right? The tangent is 1. So let's try to make an expression with, let's see, alpha and beta and pi over 4. Maybe we could do that by using tangent. So let's say, I'm going to say, okay, tangent of alpha is equal to, looks like 1 divided by 3, right? Tangent of beta is equal to 1 divided by 2. Now let's see the tangent identity to figure out what the tangent of alpha plus beta is. So that would be equal to those two tangents added together, so 1/3 plus 1/2. That would be equal to 5/6 because it's 3/6 plus 2/6. And divided by 1 minus and the two tangents multiplied together, which is that, right? So that would be equal to 5/6 on top, and on the bottom it would be 1 minus 1/6. And that would be 5/6 over 5/6, which would be equal to 1. And so the tangent of alpha plus beta equals 1, so that means that the inverse tangent of 1 is 45 degrees, so alpha plus beta must be 45 degrees, or pi over 4. Okay? And now it could be like another value that it also has a tangent of 1, but the other value that has a tangent of 1 would be like 180 plus 45 degrees, which is like 225 degrees. And you can see from the diagram that alpha plus beta is definitely not 225 degrees. It's going to be 45. Okay, so that's it. That was the last one on this page.